So in this video, I'm going to talk about the physical properties, the continuation, strength, setting, heat and loss of ignition, flexural strength, everything. So let's go deep dive into it. So cement, the primary binding material I already talked about. Quality determined by physical properties. So some physical properties I already explained. Here comes the other physical properties. The main physical next of compressive strength. The main physical property is called as flexural strength actually. So flexural strength often called as the modulus of rupture. It is a constant. For cement, there is a constant. For concrete, modulus of rupture is a constant for particular brand of cement or that grade of concrete. So, modulus of rupture is in what a time it is ruptured. That is that. Actually, it's an indirect way of measuring the tensile strength. Instead of pulling the cement apart directly, we applied a load in bending. So the specimen we here is the very much rectangular kind of specimen we are using here. In this test, a uh, prism shape cube, elongated cube is prism shaped. Mortar beam of size 160 mm is prepared and cured. It is then placed on supports and a load is applied at the very center of the beam, so it breaks. The breaking point gives the measure of the flexural strength actually. This property is especially very important for elements like concrete pavements, thin slabs and floorings and tiles which are uh, compression in nature. The test is standardized under ASTM C348 ASTM C348 to ensure uniform results. Flexural strength gives engineers a better clarification, a better idea of how cement mortar will behave when subjected to bending stress in real applications. So this is all about the flexural strength. Then comes under the setting time. So cement sets and hardens after mixing with water. It's a universal thing. So when cement is mixed with water, it doesn't immediately harden actually. Instead it goes through a gradual process called setting. Setting time is very crucial because it defines the window of workability. It defines the workability of the concrete. The time during which mixing, transporting, placing and finishing must be completed actually. So there are two main stages: initial setting time and final setting time. So initial setting time, this is when the paste starts losing its plasticity and begin to stiffen. Typically it should occur within 30 to 45 minutes. This gives workers enough time to handle and place the concrete. So in final setting time is, this is when the paste hardens to a completely a formed substance or formed particle shape and gain some strength to resist loads. It should not exceed 10 hours though. Several factors influence setting time, including the fineness of cement particles, water to cement ratio, chemical composition, and the presence of admixtures like accelerators or retardants. For example, in hot climates, cement sets faster due to quick hydration, so retarders are often added to delay setting. On the other hand, in cold climates areas, accelerators may be used to speed up setting. To ensure quality, standardized tests are using like the wicket needles test, um, ASTM-C191 its name, which measures penetration resistance at different times, and the needless test at using ASTM-C266. This is all about the setting time. And here comes the heat of hydration. So exothermic reaction. What is exothermic? When cement reacts with water, the chemical process called hydration begins. This reaction is exothermic, meaning it releases heat. The total amount of heat released is called the heat of hydration. The rate and amount of heat depend largely on the chemical compounds present in cement, especially tricalcium silicate and tricalcium aluminate. A high content of these components or compounds results in faster reaction and higher heat generation. So other factors like water to cement ratio, fineness of grinding, and curing temperature also influences this property. Now, this heat can be both beneficial and harmful. In cold weather concreting, the heat helps maintaining curing temperatures, preventing the concrete from freezing. However, in massive concrete structures like dams, too much heat can lead to differential expansion and cracking. Therefore, special cements called low heat cements are sometimes used in large structures to control thermal stress. The standard procedure is to measure this property is given in ASTM C186. Next comes the laws of ignition. So, what is laws of ignition? It is actually a measure of how much weight cement loses when it is heated to very high temperature, typically between the range like 9,000 to 1,000 degrees Celsius. So why this test is more important? I'll tell you. Because it tells us about the cement storage condition and quality. If cement has been stored for too long or improperly exposed to moisture, it undergoes unwanted reactions like prehydration on its own or carbonation. So these reactions reduce cement's reactivity and strength. So I'm talking about the cement which is prepared in the factory, and it will be kept in silos, very huge structures to carry cement. So this reaction reduces cement's reactivity and strength. Similarly, adulteration during transport, such as mixing with dust or impurities, can also increase the loss of ignition values. So for high quality cement, the loss of ignition should be within permissible limits, generally like less than 5%. And a standard like ASTMC 114 and AASHTO T105 provide the testing procedure. A high level of loss of ignition value is the warning sign that the cement may not be performed well in construction, and therefore it should be rejected or used cautiously. Like if we are placing a cement bag for so long, what happens, it may tightens hard strata, and we can't able to use it for any other purpose. So that is main because of the laws of ignition, it can make the material of the cements become harder. So we can't able to use such kind of cements for the uh, making buildings or making concrete as of now. So that's all about, I'm going to talk about the concrete technology. We talked about what is concrete, and what how the concrete is the prime material, and the main physical properties of cement, which is the primary ingredient of concrete. Thank you.